Okay, let's go ahead and get this started. Can everybody hear me okay? Thumbs up if you guys can hear me. Great. I love it when technology works. Good morning and welcome to the session, Building Smarter Devices for a Better Life. And isn't that a great session title? You would think that this would be a crowded space with a title like that, because who doesn't want to learn a little bit more about building smarter devices for a better life? As quick introductions, my name is Lowry Snow. I'm on the IoT business development team, and I'm joined by two terrific co-presenters. First, Syed Rehan, who's Senior Specialist Solution Architect of IoT. Also, be forewarned, he's from the UK, but he's still a good chap, so we won't hold that against him. And finally, we have a very special guest joining us from Belkin, Carl Johnson, who is Senior Director of Product Management for Smart Home and IoT. We've got some great content prepared. We're really excited to share it with you guys. Just real quick, who's here at reInvent for the first time? Anybody here first timer? Great, we have some common ground. This is my first time presenting to a silent session group, so you're going to have to kind of be patient as I work with this new format where I'm not able to riff with the audience as much as I'd like. So let's go ahead and cover what the topics that we'll go over today. First, I'm going to talk about product innovation and the smart home. I'll then give an overview of the AWS IoT Services. Next, Syed will bring the technical content. He's the technical IoT expert. We'll talk about what other customers have done to build smart home devices with corresponding reference architectures. And finally, Belkin will share their experience building IoT devices and part of their journey migrating to the AWS IoT Services. And finally, there will be time at the end for Q&A, so have some great questions ready. You'll be able to use the mic up here, and we'll be able to answer as we can. So with that, a quick summary of the things that we expect you will learn in this session. Number one, you should be able to learn how to accelerate your product innovation by leveraging the AWS IoT Services. Second, how to kind of transform your products into the next phase of their evolution. And third, learn from customer examples. What have other customers done to build smart home devices? And finally, just me going off piste, our goal is to help inspire you. We love working with builders that are crafting interesting IoT solutions. We love hearing those stories, and we hope that this session helps inspire whatever you guys are building today. So to start, I'm going to recap a little bit of the smart home session at reInvent last year. There was a great session, and we talked about a few things as we presented the smart home solution space. First, we talked about the opportunity size of the connected home market. I could bore you with all of the stats and details of this, but the summary is this. There is the opportunity of having billions of connected devices that will ship and get connected to the internet over the next few years. We talked about the various use cases, adding IoT and connectivity to these devices. Smart home automation, for example, smart TVs, smart lights, smart appliances, home networking devices, home monitoring, home security devices like connected cameras. We talked about all of these possibilities. We also, in art of the possible fashion, talked about being able to use Amazon FreeRTOS and Greengrass to add connectivity to a range of those devices, like smart TVs, like smart connected cameras, smart door locks, smart lights, home networking products. What's great is to be able to share a year later that all of these companies that heard about the AWS IoT services were able to leverage those services and actually build IoT platforms and launch products into market with the AWS IoT services. From the iDevices smart light switch with the Alexa service integration, to a smart baby cradle from the company CradleWise, to a smart pet feeder from PetSafe, to Vizio smart TVs, to Bose speakers with Alexa integration. All of these companies today are leveraging the AWS IoT services, deploying and managing thousands and sometimes millions of devices in production. And that should be a great story for you as builders to know that many companies have gone before you and have proved that the platform can help you scale as much as you'd like to scale. So with that, I'm going to talk a little bit about product innovation and the smart home. And I'm going to get a little bit into product innovation theory here, leading into the AWS services and then the technical content. But we like to think of product innovation as a continuum. It's not a final destination. It's not an end point. It's something that happens and gets refined over time. And you can look through various points of history and various product types to see what that evolution looks like. You can start with something as simple as fire. When we discovered fire millennia ago, we didn't just stop with the discovery and use of fire. We eventually crafted candles to make fire and light portable. And from there, we eventually harnessed electricity, used light bulbs to light our homes, our cities, and other things. But that didn't stop there either. Today, all of us get to experience the next evolution of the light bulb into what is now the smart light bulb. And isn't this a great thing? We now have the ability to remotely monitor and control our lights from anywhere around the world in all kinds of devices. And you can look through various device types to see what that evolution like. For example, the wheel. The wheel was discovered, that eventually turned into a cart, and then eventually a horse-drawn carriage, eventually leading to the automobiles that we have today. And just imagine where that's going to be 10 or 20 years from now with autonomous driving technology. Now, why do we talk about product innovation? We understand that you as device builders are constantly tasked with having to iterate your products and innovate your products. And we understand and appreciate that that's no small task, it's no small challenge. So we have that top of mind as we develop our IoT services and solutions to help you iterate and build that innovation into your devices. And as we talk to you as device manufacturers, we know that you're thinking about what is it that motivates people, whether it's cave dwellers in times of old to those of us today, to bring innovation into our homes and our dwelling spaces, our living spaces. And we've really you can look through history and see that there are three motivations that drive us to bring these innovative products or things into our home. We're always looking for safety and security, how to improve the security perimeter of our dwelling spaces. Second, how to improve the quality of life. And then third, how to improve the way that we're efficient, or our efficiency, or how to save money. And in the digital era that we're in today, this is a great opportunity for you as device builders to leverage the latest advancements around machine learning and artificial intelligence to even make devices that make our homes more safe, or to help us be more efficient, or to help us save money, or to improve the quality of life, which is kind of an exciting time to be a device builder today. At AWS, we meet with countless companies. They're in the process of analyzing and exploring how to add IoT and connectivity to their devices. And as we meet with these device manufacturers, we find that companies usually with products fall into one of three categories today. First, there's the category of having a device that doesn't have any microelectronics. So examples of that would be a toothbrush, blinds, a connected pet collar, where these companies have had traditional products without any microelectronics, and when they think about an IoT platform, they have to start at the very beginning. What kind of chipset am I going to use? How do I add a connectivity module to that? How do I just do basic command and control for my IoT device? Different set of concerns from the second category of product manufacturer, where they've been doing something with electronics, maybe a microcontroller for a while, but they haven't worried about connectivity. So they have to think about connectivity plus fleet management plus OTAs, over-the-air updates, to add security to those devices on an ongoing basis. And then there's a third category of device manufacturer where companies have come to us and say, look, we've been doing IoT for a long time, or we've been doing something with a device that's connected to the cloud or the internet, but we need help really taking that device to the next phase of its evolution. How do we make it smarter? How do we add machine learning or predictive maintenance or condition monitoring to that device. So I'm going to pause here and just ask you guys a question. How many of you are in the process of working on an IoT device today? Just raise your hand if anyone's thinking about that. Okay, great. So how many people are in that first category? Adding a chipset to a device that doesn't have any form of chipset yet. Anybody in that camp today? What about the second category? So these are devices with microelectronics worrying about connectivity. You're in that category. Great. Anyone in the third category, the advanced place? Great. Good to see some hands in some of those. That's wonderful. Because we have that in mind as we develop our IoT services. And when we meet with you, we think of an IoT solution as having 3 layers to it. At the foundational layer is the matter of simply getting devices connected. One of the common questions we get asked is, all right, I have a device, doesn't have any connectivity. How do I just simply add a chipset, a microcontroller, and get it securely connected into the cloud? And then once that's all done, that base layer of your IoT platform, the second layer is, okay, once I've got devices connected, how do I work on provisioning those devices at scale? How do I manage that fleet of devices? How do I ensure that those devices are securely updated on a regular basis? That's the second layer of your IoT platform. And then finally, the third top layer, and I think this is kind of the most important layer. Once I'm collecting all of that data and I have it available to me within the cloud, how do I do advanced analytics on that data? How do I derive decisions or derive value from that so that I can make decisions that impact the devices and the customer experience? And if you think about these 3 layers, this is precisely how we've crafted our AWS IoT services. I'm not going to have a lot of time to go deep on each one of these services, so just know that there is a session that will cover these different areas and individual services themselves. But at a very high level, on the device side, we have Amazon FreeRTOS that helps you connect microcontroller-based devices. We have AWS IoT Greengrass that helps you connect microprocessor-based devices easily and securely into the cloud environment. On the connectivity side, with our cloud control services, we have IoT Core, which is a message brokering system with a rules engine, the ability to do advanced processing of the data going into your cloud environment and back out to your devices. Second, we have Device Defender, which is a security model for your devices. And third, we have device management, which allows you to manage your fleet of devices at scale. And last but not least, we have a set of analytics services that allows you to analyze that data that you're collecting, to inform your product teams, your marketing teams, how to make better devices and do more intelligent things. And with that, I'm going to go back to the previous topic. No matter where you're at with the product design, the product lifecycle, the devices that you're supporting and building today, we have services that will help you make that phase change to the next iteration of whatever would advance the utility of that device to make that customer experience more interesting. So for example, if you're on the left-hand side, a non-electronic device, we help you choose a chipset that's qualified with FreeRTOS. We help you do basic connectivity, setting up your security model and architecture for secure communication into gateways into the cloud. In the middle layer, we help you add connectivity, but also help you easily send over-the-air updates to your devices, easily manage your fleet of devices, further enhancing that customer experience by adding an IoT layer. And then last but not least, if you fall into that third camp, we help you migrate to the AWS managed services so that you can do the advanced analytics, so that you can add machine learning models to send those models to your device for local machine learning inference. So really, those devices become more intelligent things. Not only that, those devices can improve their functionality over time as you send over-the-air updates to those devices and improve machine learning models. Keep this in mind because when Syed joins us in a few minutes, he'll be talking about reference architectures that fall into each of these 3 categories of devices. And with that, here's the closing thought for my section of the presentation. At Amazon and at AWS, we like the concept of flywheels. A flywheel for us is something that is ever improving in some fashion. So at Amazon, for example, our philosophy is if we lower prices, then that will invite more customers. And by inviting more customers to take advantage of the Amazon service, that allows us to further lower prices. And as we continue to lower prices, that again invites more customers. I would argue that it's IoT that allows you to create a device innovation flywheel. What that means is that as you add IoT to your devices, and as you decide to collect data, and as you send that data into the cloud, and as you do analytics on that data, that then informs all kinds of decisions that you decide to make about your product roadmap. Also, that further enhances the customer experience as you then integrate into the customer experience those improvements that could be made to make your product more useful. And as you make your product more useful and valuable to the end customer, that in turn allows you to collect more data and continue that process. So with that in mind, inviting Syed up onto the stage with the technical information.
Thank you. Okay, can everybody hear me? I'm guessing everybody can hear me, right? Just by raise of hand, well, before I start that, just by myself, I'm a specialist solution architect based out of London, covering EMEA region. I work with our customers ranging from startups to enterprises, helping them adapt with AWS IoT and scale with AWS IoT. So by raise of hand, how many have actually used AWS IoT or played with it? Okay, yeah, that's nice. Some pretty familiar faces, that's nice. Good to see that. Okay. So I'm going to talk about 3 use cases, which Laurie showed picture of a dog collar. Second one would be a coffee machine, and the third one would be a smart hub. Now, first one is I worked with a customer recently, and they wanted to actually adapt AWS IoT and get the device state and location awareness of the device. So in this case, it was a dog collar, but it could be any smart devices. It could be a kettle, a microwave, any devices imaginable in a home can be made smart. And with the customer, they wanted to understand that, okay, what do we know once the device goes in the field, if it's going to die in 1 year time, 2 years time, how do we know that? How can we make sure that this device is performing optimal to the best desired state and giving the best customer experience to the user? So imagine I have a dog, and I take my dog to a park, and he spends a few minutes, 10 minutes here, 5 minutes there, 2 minutes there. But based on the geolocation, I can see that, okay, he spent more time over there, but that's not good enough for me. What I want to understand is that, okay, whether based on the microcontroller which they adapted contained sensors like accelerometer, gyro, and stuff like that, they wanted to know that, okay, what is the energy state of the dog? What is the health of the dog? So when I'm going to the track, is he pumped up by not coming back? Is he energized? Is he, ready to go to bed? Or is he hungry? Because sometimes I can see the pattern with my dog on my mobile app, understand, okay, what is the state he's going through. So let's look at the baseline architecture. So what you see here is a baseline architecture which we gave it to them to say that, okay, you could test out proof of technology, proof of concept, and then scale it. What they did, they used Amazon free RTOS, which is our microcontroller operating system, gives you the capability of BLE right outside the box, gives you the capability of security right outside the box, gives you the capability of over-the-air update, OTA, right outside the box, and gives you the capability of making sure the device states are known at the frequency of the data coming from the devices at customized according to your need. So what they did, they added microcontroller with Amazon free RTOS, made connection to AWS IoT Core. AWS IoT Core is our MQTT broker in the cloud. That's the main point where the data comes in from the devices. Then we have AWS IoT device management. So Laurie touched on the device management earlier. This is where you manage your devices, scale it, and it basically gives you the a single pane of glass for maintaining your device state and control. Device Defender, AWS IoT Device Defender is a service which basically gives you the capability to audit your devices to make sure they are secured and adhering to the standard of your organization policies. Then we have Amazon SNS. Most people have probably used that. It's on the cloud aspect of it. So our platform gives you the capability to send notification based on the triggers happening on the device. So if the device is out of bound and is basically has breached the policy, then you can get triggers sent out to Amazon SNS. CloudWatch gives you the capability of operational data in the form of log and metrics. So you can run analysis on it to say that, okay, how is your device behaving? Then we have on the bottom part of the AWS Cloud block is Device Shadow. What is Device Shadow? Is a state of the device in the field. And then we have IoT Rule. So IoT Rules gives you the capability to fan out the data or branch out the data using SQL-like query within the AWS environment and understand that, okay, whether the device is in a healthy state or non-healthy state, and if the preference is set by the user, i.e. myself on my mobile phone, to say that, I want to know when my dog's state is if he's lethargic, is he ill? How would I know that, the well-being of the dog? These are the things I could set. And Lambda is our serverless function where you can, run your code without having to spin out EC2. Now let's look at our reference architecture diagram, which they used this baseline and they actually ran with it. So to start off with, I did the microcontroller with Amazon FreeRTOS and a couple of sensors, which I mentioned earlier, connected to the cloud using AWS IoT Core. Then they went a little bit further because, as Laurie mentioned earlier, we need to understand what the data is all about, because these devices create tons of data in the form of petabyte, and we want to basically understand that, okay, what is this data valuable, because you want to take actions on those data. So they used our ETL service, which is extract, transform, load in the form of AWS Glue. And then they run serverless queries on that data, SQL queries using Athena. And then they built it QuickSight dashboard to understand the BI aspect of it for the consumption of our product owners, business analysts, and so on. And on the bottom part, you see Amazon Cognito is our authorization service. So to encapsulate the whole scenario, the use case is when I'm home, I don't want to basically go to the cloud. I would authorize from my mobile app and basically make the BLE connection to the dog collar and understand the state of the device, and understand the energy and the well-being of my dog locally. When I'm in the cloud, when I'm remote, and I could basically connect to the cloud and understand that what is the state of the device and the well-being of the dog. So that was one use case regarding dog collar. Let's look at the second one regarding the coffee machine. So with this customer, they had millions of devices all across EMEA. They wanted to go global, go from million devices to hundreds of millions of devices, and utilize our service and leave the underlying heavy lifting on AWS and have less technical debt, but more time is spent by their developers, their technical people, to enhance the business and accelerate the customer experience. So in this case, I have a coffee machine at home, and I know I drink a lot of espresso. My wife drinks a lot of cappuccino. We all have sensors on the device to say that, okay, well, you're going to run out your 30% or 20%, but that's not good enough. What I want to understand is that, okay, if it's 30%, but what does it mean? What does it equate to in terms of the coffee cup, right? We would only understand that if we actually analyze the data on the device to say that, okay, this is what's happening. So what the customer did, they had a couple of devices. So this is the first state of how they actually updated the devices of this use case. So they had coffee makers which were sold 4 years ago. Some were sold 3 years ago. And they didn't want to leave their users of version 1 of the coffee machine behind and just basically make sure the new and shiny one came out. Doesn't mean that you stop updating it. So they use the feature within AWS IoT device management called fleet indexing. Fleet indexing gives you the capability to dynamically group the devices, whether it's version 1, version 2. So you have a yay big list of devices which needs firmware updating to latest. And you want to go from here to here, which means that they're all updated and grow the size that these are latest devices running all of them unified firmware. So how did they did that? They did it in a quick 4 steps. They got the firmware, and the developer signed the firmware, uploaded to S3, got the pre-signed URL from S3, used the API, or you can use the dashboard of IoT, came and created something called IoT jobs. So we have a feature called IoT jobs, which means that you could create a schedule on the cloud, and then when the next time device makes the connection, the device gets informed if it requires updating. And if it doesn't require updating, you're all good. But if it doesn't, if it does require updating, you will say, well, you are one of those dynamic groups devices, version 1 of the product, or version 2 of the product, or version 3, and we need to update you. So in this instance, they actually monetize the business by utilizing the over-the-air update right all the way from version 1 to version 3. How did they monetize that? So for example, I pay subscription of £10, 10 Great British pound for a year. And they scaled it from using these services to all the million users. And they said, okay, you know what, we'll give you a premium service, so which means that you will know that you got 6 cappuccino cup left and 3 espresso. So which means in 2 days' time, you're going to run out. And after that means it's going to be cranky waking up, which is no good. So I subscribe to the premium service and say, okay, I'll pay £10. Now, the business monetization can only be done because they didn't left out the users of the previous version 1, version 2, as well as given the same feature to those guys. So they moved along all of them in one go. And coming back to the point of in terms of the device updating, so the developer actually will upload it and the job will be created. And once the job is created, the device makes the connection. Whenever he makes the telemetry connection to the MQTT IoT core, it will get informed that you are version 1 or version 2 of the device. You need to basically download this firmware. And the device will download it. It will do the check on the edge and upload it, update the firmware. And you can schedule it to say that do it only on the downtime of the user. Don't need to do it when it's not on the downtime, so otherwise it will impact the customer usage of the product. Device updates, sends a notification. You move the device from here to here, which means that it's been updated and we don't need to update it. So you could move all your product line in one go. So this was the baseline reference architecture diagram we gave them. So let's look at the reference architecture diagram they used from here, and they ran with it and basically deployed it to hundreds of millions of devices globally. Okay, so I've already talked about the IoT section of it and the over-the-air update section of it. Let me talk about a little bit on the JITR. JITR being just-in-time registration. So the recommended process is that you should have a unique identity. You may ask, okay, what's a unique identity? So their coffee machines are actually developed and assembled and manufactured in Asia. So the recommendation we gave to them, you should actually give unique identity to the device when it's on the factory floor. Do not give unique identity, give the shared identity on the factory floor. And once the user purchases it, once I purchase the product, I want to basically associate it as a unique product to me or my family, rather than shared identity, which means that you will have a one-to-one correlation. So this is exactly what they did. The device get manufactured, I purchase the device, I get a mobile app, I already have an account with the customer, I scan the product, QR code on the back of the coffee machine, and it basically goes to the cloud, as you can see on the box over there. It checks using our Amazon API gateways, our gateway service into the cloud for making API calls, and it checks that my profile exists or not from a mobile phone. And if it doesn't, it takes me within the app to say that, okay, go ahead and create a register for the new profile. And if I'm registered, it associates with it. And the benefit you get straight away, you have registered your user straight away. You have assigned unique identity of the device to me. as well as that, you know that if I buy any further product, I will be associated to it. Now, here is the benefit from the business monetization perspective. They looked at the data and they say, okay, this is a premium user who's paying £10 a year, and he's asked for notifications and things like that for it to make sure I get notified. So now I get notified to say that, okay, your coffee is going to run out in 2 days. Would you like to basically order it either one of your chosen retailers or Amazon? And it will come and your life goes on. So it's a smooth transition by optimizing the product all the way from version 1 to version 3, as well as business monetization of the product line. So, if you think about it, hundreds of millions of devices, subscribed customers of £10 a year, that's good money. Now let's look at the third use case. So this is the third use case we're referring to here is the smart hub. So this customer of mine basically came to us and say, well, I have these devices connected. I have the data, but I want to do something special about it. And I'm one of their customers. So let me tell you a use case. I have this device. I have a profile associated on my phone or using Alexa on the cloud system there. Okay, Syed's profile. It knows my preferences in terms of I like horror movies and my other preferences in terms of restaurant delivery companies and stuff like that. Now imagine this customer actually has a smart hub and they have associated devices connected, form of sensors, thermostat, kettle, fridge, TV to the smart hub. And what they wanted to do is say, okay, well, as a premium user, you subscribe to this service, we will basically apply machine learning for you. We'll basically give you intelligence. So you may ask, okay, what form of intelligence here? Now, I basically have a profile. I know I've set it up in my profile to say that comes Friday, my wife says, okay, I'm going to take the kids to her parents, and I'm not allowed to watch horror movies while my daughter is home because she gets scared. So I'm only allowed to watch when she is not home. So the profile notification will say, I have not detected any activity in the house. The smart hub will send the notification from last 2 hours. Usually by 6 o'clock, the activity is quite heavy in your house. I'm seeing no activity. Would you like it to switch to Saya's profile? The notification will come up on my phone. And I'll say, yeah, why not? So I know the moment I press the button to say that associate with Saya's profile, by the time I get home, few things will happen. But let me tell you about those few things. First, let me show you the baseline architecture diagram. So as you can see on your left-hand side, we have a smart hub running AWS IoT Greengrass. AWS IoT Greengrass gives you the capability of running Lambdas locally on Smart Hub. It also gives you the capability to run machine learning inference on the hub at edge. So what it actually means is that the data, the profile, which I basically have selected, the machine data which is going from the edge Smart Hub, and all those associated sensors going to the cloud, and we have a service called AWS IoT Analytics, is going in there, we're normalizing the data, and then we are using something called Amazon SageMaker, which is our machine learning service. So we train the model of Amazon using Amazon SageMaker on the cloud, and then we deploy the machine learning inference from the cloud to the edge. Now let me tell you a use case what actually happened. So what I want to do, the moment Saya's profile has been switched on, and I get home, say by 8 o'clock, the sensors detect Saya's gone home because of the connectivity from my geolocation from my phone and the hub connectivity of the profile, as well as my selection of the profile earlier. I can go freshen up. The hub can make the order from the restaurant delivery service to say that, his preference of choices is this, and I usually pick those. And it knows based on my order preferences because they train the data on the cloud. So by the time I freshen up, come downstairs, and you can see that my food has arrived. So that's good. That's one less thing for me to do. Now, I get the food, and I say to Alexa, Alexa, switch profile. And then it knows that, okay, well, Syed has said profile, I've already ordered. I know he likes horror movies. Let's turn the TV on and switch it to the list of horror movies he likes. Boom. That means full weekend of horror movies binging. And this gives the capability for me, so without doing these tedious tasks, I can just leave the machine to take care of it. So this was the baseline architecture we gave them. There are a couple of things going on there. So from the SageMaker, I already talked about the training the model, deploying on the edge, from the cloud to the edge. On the bottom part, we have Amazon QuickSight, which is our BI service. So by using AWS IoT Analytics, you can normalize the data and prepare it for BI, and you can consume it from Amazon QuickSight. Then we also have a service called AWS IoT Events, which they're using to fire off other triggers within the AWS cloud environment in terms of taking care of usual activities like cleaning up and stuff like that. Now, let's look at the architecture diagram which they actually ran with it and went into production and deployed to hundreds of millions of devices all across the globe. Now, what you can see here, they associated my profile with the Smart Hub. My preferences are stored on the cloud in Amazon Aurora, which is our RDS service. They also have a time series database which contains all the historic data of the device. They also are using Amazon Cognito, and there are two parts here. One, I'm actually using and logging in using my mobile app, which is, by the way, Amazon Cognito is our authorization service. They also have their support staff logging in as and when needed for them to reset, debug, or understand the state of it when it goes wrong as a backup feature. And if you can see, all the data is going in, once it's normalized, into SageMaker. They put it into S3 bucket. They have pre-triggered actions that it takes that and deploys it using IoT Core onto the edge, which is Smart Home Hub, the smaller box what you see on the left-hand side, and it's running those. And also you can see Alexa skill as part of the association within my profile. Now, we also have Amazon Pinpoint, which is on the bottom right, and that feature gives us the capability to engage with the customer in the form of SMS, email, as well as mobile app notification, which I talked about earlier, which means that switch to size profile, yes, and that's what happened. And it all brings it together harmoniously all the way from the Smart Hub, which has all the associated sensors attached to it, sending all the data, and the Lambda, which are running on edge locally on those Smart Hub, is understanding that, okay, what should we do? So in the case of there has been no action the past 2 hours in the house, it's been eerie quiet. Does that mean that there's nobody home? Yes, exactly, that's what it means. Take action, send notification to me, switch it to size profile, yes. So you could take actions on edge by utilizing AWS IoT Greengrass, as well as apply the machine learning inference locally, which means that, as I said earlier, I come home, it detects a side home, yes, and then switch it to my profile to say, send the order to the restaurant, the order will arrive in 15 minutes, and the notification will come up on the hub, or Alexa, your order is already on the way or it's coming. I can get ready, sit down, get the order, start binging movies. So with that, I would like to welcome Carl Johnson from Belkin and understand the journey Belkin has taken of adapting AWS IoT and scaling with AWS IoT. Thank you.
Thank you, Syed. Can everybody hear me okay? Yep. Yeah, my name is Carl Johnson. I'm Senior Director of Product Management at Belkin and responsible for Wemo, IoT, and Smart Home. And before we start, I want to give you a quick overview of our company and the history, and then go into a high-level overview of why and how we switched to AWS IoT. So if we start with the company history, so we're founded in the 80s and always been a premium vendor of cables and accessories for electronics. And about a year ago, we were acquired by Foxconn, which is one of the world's largest electronics manufacturers. And we've also been spreading our wings to IoT and networking in general. So we have 4 brands under our belt. So Belkin is still the cable and accessory brand. Then we got Wemo, which is a smart home and IoT brand. Then we got Linksys for networking, which you're probably very familiar with. And then Fin, which is our IoT solution for water management. So I'm going to focus on Wemo here today. And to give you a little bit of background on Wemo, it's been around for a long time, and we've been pioneers in the industry. And we have a lot of the world's first under our belt as well. As an example, we were the first one to support Alexa back 5 years ago. We were the first one to do Works with Nest, which was now deprecated and is now Google Assistant. And also we were the first one to adopt Apple HomeKit's software authentication. Yeah, and sometimes we've been on the bleeding edge in the industry. So today we have about 4.8 million devices connected and 5 million apps installed and actively used in around 3 million homes. And this is distributed around 200 countries. And I'm sure that 4.8 million has already gone beyond 5 million now after Black Friday. But I haven't looked at the numbers yet. But this is the products we currently offer in the US market. A Wi-Fi smart plug, do-it-yourself retrofit switches and dimmers, face cut dimmers for your lighting. But we used to do much more than that. We also have a legacy of devices we still support today, including appliances. We used to do coffee machines, crock pots, purifiers, and many other devices. And we're not selling those anymore. We discontinued them, but we continue to support them. And we're not exiting the appliance category. We're just partnering instead of making it ourselves. So we're moving actually, as of next year, our firmware from our POSIX-based MCU over to Amazon free RTOS. So we're going to use a module for all our 2020 and beyond Wemo products, but also partnering with appliance manufacturers and putting those in appliances. So that's an important piece on the firmware side before we go into the cloud side. And if we look at the cloud side, in the early days, we just had a desktop underneath a desk in our headquarters in Playa Vista, California. And then when AWS came along, we moved our code base to the cloud, which was a big step. And but still running our home-brewed cloud, and we have our own home-baked application server. And then as of this year, we're moving to AWS IoT Core, and it's not as simple. Given all the legacy we have, it's not as simple as doing it with a flip of a switch. And we haven't lost this publicly yet, but it's already running, and we're dogfooding it internally at the moment. And the reason we decided to move is we have had some challenging scale our cloud, and we have a lot of scalability issues, especially because we have so much fluctuation in amount of nodes, especially seasonalities. Like Christmas, our cloud load increases about triple, at least triple. And that's not only because we sell a lot of Black Friday, it's also because a lot of the products like the smart plugs are purchased for Christmas tree and Christmas lights and being put in the box and then open again the next year. So they're not offline, or they're offline 11 months of the year. So we have a very dynamic cloud, so we're looking to solve that with AWS IoT. And that also comes in with uptime and maintenance, which can be difficult with such a dynamic load. And then state integrity is another thing. We have quite an old architecture we're still supporting today, so we wanted to improve the state integrity and the response time of our architecture. And then last but not least, cost as well. We expect significant savings on moving to AWS IoT. So if we start with remote access on the transitioning side. So today we have our current firmware running on a POSIX-based MCU using TCP connection to a turn server, and we currently have about 180, a little bit over that, turn server instances running. And when Christmas hits, we scale those turn servers to many more instances, and then we scale back down again depending on the load. And then we have our application server running separately, dealing with all the logic, all the device profiles, the customer accounts, and all the stuff separately. So what we're doing now with our new devices is we're using MQTT from our Amazon FreeRTOS directly to AWS IoT Core. And then we are making a connection to our existing application server. So we're still using that. And we are also implementing a management API between those two. And initially, we didn't have a connection to our app. We're still using the REST API we have been using in the past. And now we are transitioning that also to using MQTT. And that brings me to state integrity and response time and how we do real-time status updates. So today, when an event happens or something we need to monitor and know about, we upload that or store that in a DynamoDB, and then our app is doing polling to check if there's a status change, which is not ideal. We want to get immediate response and have real-time updates. So what we're doing with AWS IoT Core is routing a state change to our application server through Lambda, but also notifying our app directly, so there's an immediate response without having to do the polling. And that's even working with our legacy devices because it's get notified through the same route. So we expect our customers to have a much better experience on that. And real-time status update and state integrity is going to get more and more important in the future, especially because we are kind of in the early days of IoT. You would think we've been in this industry for over 10 years. You would think it's not early days, but the common people are actually catching on now. And we have statistics that show that about 85% of customers shopping for smart products last year were buying their first connected device, which is huge. And this is really catching on. And this year, it's opposite. 85% of people that are buying their second or third device. So with more devices in your home, I'm not sure about you, but I've updated my home over the last 15 years, and I have over 100 connected devices in my home, and I get really tiresome trying to control them from a phone or even with voice, because when the voice came along, it gave a big vitamin boost in the market, and we saw a lot of these actuators, smart locks, bulbs, and irrigation systems, IP cameras, all this stuff that you can connect, but it's all actuators typically. There's not a lot of input devices in the market now, and that's what you need when you start having your home crowded with connected devices. You want to get some input devices and have different means of controlling them and also automating them. So we think that's a category, even though sensors and input devices are nothing new, it's an emerging category that is going to drive the next wave of IoT. And then when you have that data, we can start looking at the AWS IoT analytics and looking at machine learning and AI. So we're kind of preparing us for the future from that point of view. And when I mention input devices, I mean, obviously you can do today, you have your voice, you have time, you can put up schedule from dusk to dawn or something like that. You can do geofencing. You can also buy motion sensors, but there are a lot of inputs we still don't have today to make the home truly intelligent, and we're excited to ride that wave. So with that in mind, we're going to be showing some new exciting products at CES in a month from now. So if you're there, we hope to see you. We're going to be in the South Hall. Yeah. So with that, I'm going to wrap up my part. And if you have any questions, we got our cloud architects here in the crowd. So I encourage you to come afterwards and find us if you have any technical questions. Thank you.